So, what if we get a circuit that looks like this? So, I'm going to let you look at the circuit for a minute, and I'm going to ask you a couple questions. You can pause in between, and that way you can see if you got the answers right. So, if I had something like this, I'm going to ask you first question. How many resistors are just in series? Give me your answer to that one. And then, how many resistors are just in parallel? Take your answer on that one too. So the answer to those, there are 0 resistors in this thing that are perfectly in series and 0 that are perfectly in parallel. This is a really weird circuit. You get this one, you go yikers, because things are in parallel and in series at the same time. So what we're going to learn this class is how to break these more complex circuits down with something called a delta to Y conversion or transformation, depending on who is telling or teaching it. But essentially, it's a little trick that we use to be able to take a circuit like this and break it down into something that's solvable. Because right now, we can't, when using the normal techniques that we have right now, solve this easily. So in the next couple slides, I'm going to go through and show you one strategy of how, and I think it's the simplest strategy, of how to break this down into a simpler and solvable circuit. So this is kind of a cool slide. This is a good visual representation for how to go from a Y circuit to a delta circuit, and then also how to go from a delta circuit to a Y circuit. So, excuse me. What this is saying here is we have our 1, 2, and 3 forming that little red delta or that triangle. The symbol of delta looks like a triangle. That's why we call it a delta. And then the Y looks like a Y. So remember, the length of these wires that connects the resistors in between them can be moved, changed however you want. So it's kind of easy to see how this could be a Y at node 3 right there, or at node 4. So with a little bit of mathematical magic, we're going to be able to take one of these conversions, one of these, either the delta circuit or the Y circuit, and convert it into the other. And usually that's going to simplify the problem in a way that's going to allow us to solve it. So you don't have to always convert every delta and every Y. Usually we pick one of them, and that's going to usually propagate through the problem and solve the rest of it out nice and easy. So we're going to go through that in the next couple slides on actually how to use that. For here, though, this is the kind of thing that you want to look for. And again, if you look at node 1 right up there at the top, you see how they all come together as a point, and you get that nice little triangle there, that nice little delta. The wires in between the resistors can be moved or manipulated or grown or shrunk. For our calculations, there is no resistance in those wires, so therefore they're purely mathematically just connection points. So if you want to branch that delta, that triangle, and open it up to a square, that's another way of looking at it. If you want to make it even like rectangular, however you want to do it, as long as that the output of R0 connects to the input of R1 and R2, whatever that looks like in between there, as long as it's mathematically the same, then you're good to go. So in the next one, we're going to look at this a little more in detail. The Y to delta transformation, or delta to Y, is a reversible transformation, which is what that red arrow back and forth is saying. You can mathematically take the Y circuit and get to the delta circuit, or the delta circuit and get to the Y circuit. So in solving different types of problems, sometimes it might be advantageous to use one versus the other. There are some other later ways of doing this, different circuit techniques and analysis techniques that'll help break it down in a different way. But usually these other ways are more laborious, and this is actually a pretty quick shortcut that can get you from one to the other very, very quickly. So on the FE exam or other important exams when you're time crunched, this is a really nice little trick to be able to use to simplify it out. It takes more memorization than some of the other tricks that we know so far. However, I think it's a very worthwhile thing to know, and you're going to have to know it for some of the ways of solving problems that we're going to have coming up. So underneath these, um, we have the mathematical breakdown. R12 equals R1 plus R2. And so underneath here, we're going to go through all of these. I'm going to work them out so that you can actually see how they work out in an actual problem. And then I'd recommend coming back to this slide again to kind of work through it one more time. You will need to know these mathematical simplifications. I might give them to you for the first test on this that we have, but after that, you're not going to get these simplifications, most likely. So you're going to need to know how to do them and how to memorize them, which they're not bad. They're very, once you kind of look at them, they're kind of explanatory. So we're going to look at that in an example coming up in a second. So on this slide, we have the y to delta transformation and the math that you need to know for it. So first, let's start with the pictures and depictions, and then we're going to talk through the math that gets us there. So in figure A, the y circuit, this y circuit is going to be able to be transformed into the delta circuit. And so the way I like to remember this is R1, 2, and 3 are opposite R A, B, and C respectively. So R1 is opposite RA, R2 is opposite RB, and R3 is opposite RC. And that is the way I like to remember it. And I'm going to try to draw it for you in one of these video tutorials coming up to show you exactly how that works out. But you can get it from here too. It's a little less clear, I think, but let's look again. So at R1, if we look down at the bottom, we're going to be able to solve what R1 is for that Y circuit. So that is going from the delta to the Y transformation, or the right picture to the left picture. And then on the bottom right-hand side, we're going to go from the Y circuit to the delta circuit, which is the left to the right picture. So I'm going to tell you almost always, at least for now, we're going to go from Y to delta. However, sometimes you're going to go from delta to Y because it will simplify things out a little bit. So let's look now a little bit more into the math. R1, which R1 is in the Y circuit, so we're solving to get the Y circuit up there. R1 is going to be RB times RC over the sum of RA, B, and C. So all of these are, this is the way I memorize it. All of these are going to be over the sum of A, B, and C, which is all of them. So the denominator is A, RA plus RB, R plus C, RC. That one's always easy. So that's the first way to memorize it. Knock that half out, you got half the problem out. And then the top half, the way to memorize it is it's the opposite one than the one you're looking for. So if we're looking for R1, then we leave out RA because it's opposite of those. If we're looking for R2, we leave out RB because it's the opposite of those. And if we're looking for R3, we leave out RC because it's the opposite of those. And that's the way you can memorize this. And once you have one, you can back solve again to get the other one. So all the ones on the right are just algebraic manipulations of the one on the left, essentially. So the one on the right, we're going to have RA over the resistor 1, so it's the same resistor on the denominator. And then on the numerator, you're going to have R12 plus R23 plus R13. So it's essentially the combination of all the different pairs that you can have, the sum of those. So again, there's ways to memorize these, and you're going to have to be able to do that. It's not that bad. You usually are going to have to memorize one for each of these sides, so R1 and RA, and then just remember the trick, and then you can get R2 and R3 and RB and RC. So you only have to memorize 2 of 6. That's not too bad. And the rest are just little tricks to get there. So we're going to look at solving one of these in a moment, and that way we can get a little clearer even. But this is the important slide. This is the one you should really spend the most amount of your time on and make sure you completely understand and memorize it. Because this will come up on the test, and this will come up on the final, and this will come up on future tests too. This material repeats throughout the class. So it's not like once and done, but you'll have this a couple different times. So knock it out now, and that way you don't lose points the whole way through the semester for not knowing it. Howdy guys, so in this one, example 2-12, simplify the circuit to determine I, the current going in at the top there in the blue line. So I'm going to solve this 2 ways. The first way is the method I solved it, and the second way is the method the book solved it. And the difference between the two, and the point that I want to make with that is, as you can see, there are 2 different deltas you could take. So right now in blue at the top from node 1, 3, and 4 is that top triangle.
That's one solution that you could take, or you can also take the nodes from the bottom, from 3, 4, 2, that triangle as well. It doesn't really matter which one you take. In this case, if you take the one from the top and you solve it out, the numbers work out evenly nice the whole way through the problem. If you take the triangle at the bottom, the numbers are a little weird the whole way through the problem, but at the very end they work out really nicely. It doesn't matter which delta you're going to take. You're going to get the same answer anyway, as long as you follow the steps properly. So that's the next bit of why I want to go through two different methods, just to prove to you it doesn't matter which one you take. There is no wrong delta, as long as you're following the conventions. All right, here we go.